The various SQL statements can be grouped into several subset languages. The first of which we'll look at is the data definition language, which allows us to add, alter, and delete databases, tables, and indexes. First, we'll create a database called myDatabase. When we execute a statement such as this, the database system won't return any confirmation unless there were an error such as the database already existing. To see that a new database has been created, we can type show databases. Next, we should select the database with the use statement to make it the default database for the following SQL statements. Now that we have a database, let's create a table in it called myTable with 3 different columns: ID, name, and history. Each column name is followed by the data type of that column and its length in parentheses. For example, this ID integer can hold 3 digits for a maximum value of 999. The exact data types available and their names varies for different database systems, but there are 4 general types: numbers, strings, dates, and binary objects. They also come in a variety of subtypes, depending on how much data we need to store. For example, a tiny int in MySQL is 1 byte large, and a big int can store up to 8 bytes. To see the tables in the current database, we can type show tables. And to see the columns in a table, we can type describe, followed by the table name. If we hadn't selected the database with the use keyword, we would have to specify what database to use, like this. With the description of the table, we can see the column name, data type, and max length of each column. We can also see some additional parameters that we could have defined, such as adding a default value, or disallowing null values by adding not null as a modifier. A null value indicates that the field's value is undefined and is allowed by default. We could also have made the integer column numbered automatically with the auto-increment attribute. This modifier also requires the column to be the primary key of the table. A table can only have one primary key, and it must have unique values for each row. Keys are used to uniquely identify the records in a table, so that tables can relate to each other. The key field also indicates that the column is indexed, which means that it will locate rows more quickly and efficiently than other columns. Index columns require more disk space and processing time to update, so they should only be used on columns that are searched often. The createIndex statement can also be used to add keys after the table has been created. For example, to create a simple index named myIndex on the name column, we write it like this. When we describe the table, it shows up as mul, meaning it allows multiple rows to have the same value. We could also have added the unique keyword to not allow duplicate values.